In Chapter 13, we're going to talk about the basics of capital budgeting. So what is capital budgeting? Capital budgeting refers to the process in which a business analyzes and determines whether projects such as building a new plant or investing in a long-term venture can be worth pursuing. This process can be very crucial to companies because the decision made usually involved large amount of capital expenditures, and they have long-term impact, and once they are made, they cannot be easily reversed. So bad capital budgeting decision can lead to millions or even millions of dollars loss for a company. Now for us, in this chapter, we try to have an overview about the vocabulary in capital budgeting. So we should be able to explain the concept and calculation and decision criteria related to the following basic capital budgeting methods, include payback, NPV, IRR, and probability index. There are two more introduced in your book, but as we will mention later, discounted payback and MIRR, the modified IRR, will not be required for this class. You should be able to identify the proper capital budgeting technique with a single project or with independent or mutually exclusive project. So before we talk about each individual technique, we want to clarify some things first. So throughout this chapter, we'll mention normal projects and non-normal projects. So what is normal, what is non-normal in this context? Normal projects, normal cash flow projects refers to the project with cost, which is a negative cash flow, followed by a series of positive cash flows. So if you look at its timeline, there's only one change of sign, which is from the negative at the beginning to positive thereafter. Now, non-normal cash flow project refers to the project with two or more changes of signs. So for example, you have cost at the beginning, which is a negative cash flow at time 0, and then year 1 and 2 you have positive cash flows, and then year 3 you have another big investment, and so that's a second change, which is from positive in year 2 to negative in year 3. And then maybe in year 4 you have positive again, so another change, which is negative in year 3 changing to positive in year 4. So that's two or more changes of signs in cash flows. And we will explain why we need to address non-normal projects later in this chapter. Another issue is with independent versus mutually exclusive projects. So two or more projects are independent if the decision about one is unaffected by the acceptance of the other. So for example, if we have two projects and you're trying to decide which one should be accepted, and if they are independent, let's say project A and B, they are independent, then if you think A is good enough, you take A, and also if you think B is good enough, you will also take B. So taking A, or say accepting A, does not affect your decision about project B, and also accepting B will not affect your decision about A. Now if two projects are mutually exclusive, then it will be different. Then the decision about one can be adversely impacted by the acceptance of the other. So if you decide to accept project A, then you will have to reject project B. If you decide to accept project B, then you will have to reject project A. That's when project A and B are mutually exclusive. So these two projects, if they are mutually exclusive, they cannot be taken simultaneously, and you can only accept one project. So usually what do we do in capital budgeting? We start by computing the statistics. So for example, we can calculate a project's NPV, and let's just say the result is $1,000. And second step is we compare the computed result with the benchmark to decide whether we want to accept or reject the project. So for example, the benchmark for NPV is 0. That's something we will discuss later. Now, if we compare the NPV result we just got, which is 1,000, with this benchmark, and since it's higher than the benchmark, we decide to accept the project. So that's a two-step decision process. You compute the result first, and then you compare the computed result with the benchmark to decide whether the project is acceptable according to your decision criteria. However, when we deal with mutually exclusive projects, we'll need to add another step in the middle of the process. We will have to compute the statistic for each project. So for example, if we have project A and B and C, we can compute NPV for all of them. And then we will have to have a runoff between the mutually exclusive project and choose the one with the best statistic. So that is, we compare the NPV among the 3 projects and we see which one has the highest NPV. So then if we find, okay, it's project B that has the highest NPV, and then we compare the project B's NPV with the benchmark to decide whether this is acceptable. So if project B has the highest NPV and its NPV is greater than 0, the benchmark, then we decide, okay, we'll choose project B among the 3 projects. If project B's NPV is still lower than 0, the benchmark, then apparently none of these 3 projects is good enough. We'll have to reject all 3 proposals. Here's a list of the basic capital budgeting techniques, and that include payback, discounted payback, NPV, internal rate of return, modified IRR, and probability index. Now for this semester, we're not really going to talk about discounted payback, and we're not going to talk about modified IRR, so we will focus on the payback, NPV, IRR, and then we'll just address a little bit about the probability index. So let's start with the payback. What is payback? Payback essentially is the number of years required to recover a project's cost or initial investment. So basically it's about how long would it take to take the money back to recover the initial investment. So essentially it provides insight into the liquidity of the investment. The calculation of payback are based on 2 assumptions. First of all, cash flows are normal, and then we also assume cash flows occur smoothly throughout the year. For example, if we have a project that has $25,000 initial cost or investment, so that's why you see this is in negative number, and annual cash flows later are shown on the timeline below. So first year we have $8,500, second year we have $12,000, third year we have $13,500, and last year we have $15,000, and this is a 4-year project. So how do we calculate the payback? What we can do is we accumulate the cash flows. So apparently at the beginning it's $25,000 negative that we started with, and then in year 1 we will add up these 2 numbers. So it will be a negative 25,000 plus 8,500, so it's negative 16,500. And this number is negative. That means we cannot recover all the initial investment yet by the end of year 1. So we will have to move on to year 2. In year 2, you accumulate 2 years of positive cash flows and add it to the negative initial investment, and you realize the accumulative cash flow is negative 4,500, which means still not enough. So you move on to year 3. So finally, by year 3, you add up all 3 years positive cash flows compared to the 25,000, and you see now you have a positive 9,000. So that means you need more than 2 years, but less than 3 years to recover, or say to produce enough cash flows to recover the $25,000. So that's why you see a little bit more than 2 years, but less than 3 years. So it's 2 plus a little bit of year 3. So calculation wise, we'll just do 2, the first 2 years, plus a portion of year 3. Now the portion of year 3, you see the 4,500 is from here. This is after year 2. How much more left to be made? And the denominator here, this is how much you are totally going to have or produce by all year 3. So when you use 4,500 dividing by 13,500, you are getting a portion of year 3 that you can use to make 4,500, so that number added to year 1 and year 2's cash flows altogether, you make enough of 25,000. So the payback of the first example is 2 years plus 0.33, or say about 4 months of the third year. So if we want to have a summary about how to calculate the payback, we try to accumulate the cash flows over years. And in year 1, 8,500 from year 1 added to the negative 25,000 from year 0 give us a negative 16,500, and you do it year by year. And so this number, this result, usually suggests how much more do we still have to make to break even, or say to recover the initial investment. And what we want to find out is, when would this cumulative cash flow become 0? So negative to positive. So some point in year 2, or say some point after year 2, that's when your negative finally turns positive. Therefore, the break-even point happened between year 2 and year 3. So you just want to do the calculation as the first 2 years plus 33% of the third year. Well, 33% is 4,500 divided by 13,500, and 4,500 is from the negative 45 of the cumulative cash flows as of year 2, and 13,500 is the total cash flows of year 3. So if we want to put a formula like that, you can write it as A plus B divided by C, but you of course need to know what is A, what is B, what is C, according to your question. A is the last period with a negative cumulative cash flow. So in our example, it's 2 years. B is the absolute value of the cumulative cash flow at the end of year 2 in our example. So in this case, it's 4,500. You don't want to have a negative number here, so just take the absolute value. And C is the total amount of cash flow during the period after A. So in year 3, remember A is 2 years, right? So after A, that's year 3, total cash flow during year 3, that would be the 13,500. So if you want to memorize this formula, you can do that, but just try to understand what each component in this formula is about. Once we get payback result, what do? We try to have a payback benchmark, and usually companies set some maximum allowable payback benchmark, and this maximum allowable payback is often set very arbitrarily, and this actually is one of the payback's greatest weakness. So usually this maximum allowable payback for the project should be set based on some relevant external constraint. For example, the time until capital providers or say investors need the money back. But the problem is, as you might suspect, in real life, managers often indicate the maximum allowable payback and set the maximum allowable payback very arbitrarily. So it becomes less scientific. According to the payback rule, we can accept a project if the calculated payback is lower, or say shorter than the maximum allowable payback. That suggests we recover our initial investment before the so-called maximum allowable payback. And we have to reject the project if, by our result, the calculated payback is actually longer than the maximum allowable payback, or say if it takes too long for us to get our money back. Here's a practice question about the payback. So you are provided with a 5-year project, and each year the cash flow is given, and apparently this project involves an investment of $1,000 and has positive cash flows thereafter. Maximum allowable payback is 4 years. The question is, how much is payback for this project, and according to your result, whether this project is acceptable. I provide the answer here. You should check your answer with mine. So apparently this project also have a payback of 2.33 years, and remember the A plus B divided by C formula, so I'm giving you the inputs of how to use that formula. And Since 2.33 years is less than or say shorter than the maximum allowable payback of 4 years, this project actually is acceptable according to the payback criteria. If we want to get payback evaluation, we would say it has the strengths. It's good indication about the project's risk and liquidity. Cash flows that occur later in the project life can be more uncertain, so payback period provides an indication of how certain the project cash flows are. So if the payback is a bit too long, the investors may be a little bit concerned about the project's risk and uncertainty and liquidity. For companies facing liquidity problems, it provides good ranking of projects that would return money early. And also, payback is very easy to calculate and understand. The math is pretty straightforward, and as long as you know the procedure, the steps involved, the calculation itself, that can be actually pretty simple. Now, payback also has its problems. For example, it ignores the time value of money concept. Remember back in chapter 4 and 5, we mentioned if cash flows do not occur at the same time, you're not supposed to add them or subtract them directly. But adding them or subtracting them directly is exactly what we do here for payback calculation. So payback period by design does not take into account the time value of money, which is a serious drawback and can lead to wrong decisions. And it overestimates how fast you can get your money back. And also, by design, it ignores cash flows that occur after the payback period. And sometimes the most profitable projects take more time to reach their full potential, but if the company has set a strict time limit on payback periods, then they may actually end up rejecting a very worthwhile project, and that would be a lousy capital budgeting idea.